Okay. Rotation is the time it takes an object to complete one turn on its axis. So, how long does that take?
24 hours.
What do we get from it?
A day.
Day and... Okay, so we are tilted 23.4 degrees, right? So this right here is what? 23.4 degrees. And what kind of motion do I get right there? Okay, which one? Which type? Rotation. So that's why I'm going to take orange and I'm going to do that. That little thing means he's going to rotate on that axis. Does that make sense? Okay. This is him orbiting. How does he orbit?
Revolution.
That is called revolution. Do you know what this orbit is called? No, orbits in an... It's an ellipse. Elliptical orbit. Ellipse. So this shape right here is an ellipse. Not a circle. Orbits in an ellipse, not a circle. Does anyone know the direction that we would do that in? Clockwise? Counter? Both?
Yeah, it's counterclockwise.
Counter.
Why is it called counterclockwise?
Because it's backwards.
Oh.
Not backwards, but it's not the clock.
It's not
It goes the other way. Okay? So, this is like 152 million kilometers. And this one is like 147 million kilometers. Y'all, do you remember that a kilometer is 1,000 of these? 152 million of 1,000 of those. Times 1,000 of those. Like, that's huge. Okay? But, like, aren't those numbers kind of close together? I mean, if we're looking at that big scale, is there a lot of difference between 152 million kilometers and 147 million? No.
Why is there a difference?
I don't know exactly why. I don't know. I don't have the answer. Yeah, I know. So, distance stays relatively constant through Earth's orbit. Distance stays relatively constant through Earth's orbit.
You seem closer to the sun when you're at the top and the bottom. Is that because that's the summer, right? The summer is there like a number? Is there a number for stop?
What does that mean?
Like from like 1, you start 1,
I don't get it.
When you start at 1, 2, 3, 4,
What are we starting at 1 for? What 1 what? No. Tell me. I don't get it.
1 day, 1 degree of a circle, 1 second. You keep counting. Does the numbers ever stop? No, not till the end of time.
Oh, he's measuring time. You're measuring time? Okay, yeah, no. It's never stopped. Repeat.
If you started the earth on the left and you go all the way around, how long is that?
A year.
But kilometers, they don't know.
Oh, I have no idea. Yeah, there's got to be some way, but I don't know. Okay? That's a good question. Those are great questions. Okay, so if I'm telling y'all that our distance is relatively pretty much close to the same the whole time, then how in the heck do we get seasons? No, that's a good question, huh? You just said how close the planet is to the sun, but I just said there's not really a change in distance from the sun. So how do you see? That's what everybody thinks. That's why we have this big, huge warning sign right here that we're gonna. Mine is red. Warning. No, this is a warning sign to let you know this is where I'm going to get you on a test. Right here.
Here we go.
This is where they would get you on the LEAP test. Seasons are not caused by distance from the sun. Earth is actually closest to the sun in, anybody have a guess on what month? January. That's not why. It's just whenever he's right there, and that's the closest to the sun. That's the point that I'm trying to make to you. I said distance stays relatively constant through his orbit. So basically, he's pretty much around about the same distance from the sun all the time. So if he's always about the same distance from the sun, that's not the cause of seasons. And I'm telling you right here, seasons are not caused by distance from the sun.
Is it like, okay, whenever we rotate?
I'm about to give you the answer why.
Okay.
But just know that when I ask the question, why are seasons caused or what causes seasons, I'm definitely going to have the answer choice, distance.
So that's not when we face that way and then the first people that face that way is,
Watch, I'm about to show you.
I bet like you could tell the people the answer right before a test and they still would go.
Well, hopefully that's not going to be you. You might want to make a flashcard that says just that. Seasons are caused by tilt. This 23.4. and revolution. And this is revolution, remember? Revolving that, like around that. So I showed you tilt, I showed you revolution. That's what causes the seasons.
So when the tilt is farthest from the sun, that's when winter comes?
Yep.
What is fall? So
I'm gonna explain that.
as it rolls in.
So let's do this. Earth rotates upon a tilted axis. As Earth orbits the sun, the blank of Earth are either tilted, it's the poles of Earth, are tilted either blank or blank, towards or away from the sun. Does that make sense? Okay, so see that? Okay, I'm going to write sun. We're going to draw some little rays. You see our little tilt right here? Look, here's your land right there. See our tilt? What are we having right there? Summer.
So would the bottom be like?
The people on the bottom,
Yeah.
right here,
It's like shorter down, but it's like.
are they tilted towards the sun?
Yeah.
They're away.
Yeah.
They're having winter.
So that's why Alaska's so cold, because that's the farthest. No.
Well-
They're not on the other side. Well.
No, it's by halves. It's by halves. In this case, everybody on the top half is having summer. Everybody on the bottom half is having winter. Hang on, I'm not there yet. Okay? Okay, now, here you are. And what's your tilt now? Away. You're not tilted toward the sun, you're tilted away from the sun. So we're going to have winter. And the people at the bottom, see how they're getting that, so they're having summer. Does that make sense? I'm gonna hang on. Y'all are asking all the same thing. I said like 4 or 5 times. I'm gonna get there. Summer solstice, June 21st. Sun rises in the northeast, sets northwest. Sun's highest path through the sky and it's the longest day of the year. Because it's the highest path that the sun has to take, so it takes it longer. It's the most distance that the sun's going to travel, so it's the longest time. Yeah. No. No. It has to do with where we're at in this thing. Summer solstice is summer. The solstice is the day that happens, that the summer I mean, basically, like, it'll make sense in a minute when I show you another picture. Okay, hang on. Winter is December 21st. The sun will rise in the southeast and set in the southwest. It's the lowest path through the sky. And it's the shortest day. Rise southeast, set southwest.
So the last sentence we had was last week.
It still is winter. In fourth grade, we're coming out.
We're coming out of winter.
Yeah, we're
Oh my goodness.
It's so cold.
I'll show you in a second where we're at. Okay?
It could be the middle.
Okay, let me break this down. So I told you that the summer solstice is when the sun rises in the northeast. So, northeast. He rises in the northeast, comes up here, and sets over there.
wow.
Okay?
That sounds pretty
You saw where my hand was? Okay. The winter rises in the southeast and sets in the southwest. So look at this compared to this.
Yeah, that
Does that make sense?
makes sense.
Yeah, when you do it, if you do it 10 speeds,
No. I watched the weather. I'm the only 11-year-old who did that. I watched that in Sports Center.
So,
Exactly.
if we imagine a flashlight at two different angles, it's exactly what I just showed you.
Yeah.
What is the sun here?
12 o'clock.
No. What's his, like,
It's oh yeah, that's
what would we feel? So it's warm. What season is it? What's the sun over here? Low. What are the rays? Spread. What are you going to feel there? Cold or cool? And what season? Exactly.
Oh, okay.
So it's the same energy because it's the same sun, right? But these are like focused,
And those are like,
and these are like
they're not focused.
spaced. We got space between them, right? They spread out. They're far. Does that make sense? Okay. So now let's talk about the equinox. That is like the word equal. Okay? We have the vernal equinox, which is March 21st. And how do you say it? Autumnal? Which is spring and fall, spring, autumn, September 22nd. Yeah, they're all the 21st except September's the 22nd, and I think it's because he's coming off of this longer distance. Rises exactly east and sets exactly west. Does that make sense? So we go like from this one, it moves over till it's in the middle, and it keeps going till it's at December, and then it just comes back. And then it just does it again. That's all that changes. We are about to have the vernal equinox.
So, in other words, the beginning of
Spring.
yes. Hopefully it'll be warm.
Equal day and night. 12 and 12. And then it's the same for everyone on earth. Not that it's the same season for everyone on earth. It's like everyone on earth experiences the equal day and night. Does that make sense? Yeah, on those days.
Does that mean that there's, like, it's hot in the January, and this
Southern hemisphere.
is hot in January?
The southern hemisphere has the opposite season of us.
I know, and then it's hot in December.
Opposite seasons, yes.
It's hot in December.
Okay, so this is the path of the sun through the sky. We got 3 little paths. The first one right here, what is it representing? The first one right here, what is it representing?
Summer.
Why is it summer?
Because it's the highest
way to
up.
go around. Higher up.
Highest path through the sky. Which one? This? That's an observer.
Like, that's where you're going to be standing.
That would be where you were standing.
Same for everyone on earth. Okay, this path right here,
Autumn.
Spring and autumn.
it's the equinox. They're the same.
Yeah.
It just depends on if it's March or September. Okay, this one right here,
Winter.
winter. Does that make sense? Okay.
Oh, never mind.
Yeah, I don't know what you're asking me. Okay, so I will give you a model, and you will have to tell me, like I might say, at this position, which season is it? Okay, so which one do you want to start with?
The one right by the sun. It's on the right.
Which one's the easiest to figure out?
The right is the one on the right.
The one closest to the
No. The easiest one to figure out is tilted toward or away. That's how you figure it out. That's the easiest thing to look at the picture and see.
Which side is it?
We're over here.
No, look, I'm talking about in which corner? She's talking about one.
So this earth right here, is it tilted toward the sun or away from the sun? Okay, what about this one right here?
2.
Okay. Now can you name something for me?
Yes.
This one, what is it? Winter solstice. Who doesn't understand? Tilted away from the sun.
I know that, but what point are you?
What are you talking about?
Where's our country?
We're at the... You don't have to look at it like that. It's by the top hemisphere. Do you know what the hemisphere is? And the bottom hemisphere. We're talking about us in the northern hemisphere. What's this one? No, they're the equinox. Okay, actually at this point, the North Pole gets 24 hours of sun on that day. Because they're tilted straight to him. Pretty much, yeah.
Oh, wow.
Okay, so we got these two.
Is that like the equinoxes?
What, Janie? Springs on the top, falls on the bottom? She's right. Vernal equinox. Autumnal.
So with the bottom, like the vernal equinox, the South Pole have 24 hours.
This is equal day and night. That's what equinox, that's equal day and night right there. Those two. Remember, counterclockwise, that'll help you figure out like which one's which. Yeah. Yes. Yeah, I don't remember either. Okay, so I'm going to share with you my dumb blonde moment from yesterday. Yes, because it's actually very, very, very helpful. After it happened, I was like, oh yeah, I so need to tell the kids about that because it made a lot of sense. Okay? So, if you look, the earth is just going around, okay? And right here I can see the angle of the sun. And then it tells me right here the path that it takes through the sky. So I was watching it, and I kept going over here looking at this, and it wouldn't change. And I'd go to my computer screen, and I'd like go put my finger on the sun as he moves, and I'm like, oh my goodness, it keeps going the same height every time. And I'm like, what's going on? So I came over here, I was like, maybe I need to go faster. So I took him and like I pulled him. And I'm like, no, it's still at the same height every time. The sun's not changing right there. What is going on? The angle's on 0. And I was like, oh my goodness, they so would like get it. If we didn't have tilt, guess what? It would stay the same the whole year. It would just stay the exact same. Look at how the temperature's right here. It would stay the same the whole time. The angles never changed. I was like, I'm such an idiot. I mean, so smart. Right? So, now, here's the real deal, people. 23-degree angle, 23-degree tilt gives us the change in these angles right here. And you can also see that the sun, when it comes through this, will take different paths. Okay? I'm going to make him go a little bit faster so that you can see it. You can see it though. Look at them turning.
Can you make it faster?
Yeah, I can. Here.
Wait, those tilted. Holy moly.
I'll show you that too.
It just keeps going. And this will be summer. This is for now summer.
So, see, my little mess up there, it does help you understand that if we didn't have the tilt is the cause. Y'all all think it's distance. It's not. Because I put us at a 0 tilt, and it doesn't make a difference. If we put it at its actual tilt, we can see what happens. Okay, I hear you. You want to see what happens. We'll put us at like, I think I did 60-something earlier today.
When you're done with this, can you go like at max and see what happens? We have
If we would have some kind of tilt like that, it's just two extremes. It's just two extremes. You don't see the four. You either are really hot or you're really cold.
Oh wow. We can put it at max. What happens when it's at the max?
Okay? Well, okay, I knew y'all would have a million questions, so that's why I put your homework is to go play on this. Okay, and then I also have this one. Yeah, I'm going to put the links on Blackboard in a minute. Okay, and it's just, you just click on it and it just takes you through each one. It's just a little bit different because look at how this path changes. Like, watch, it like jumps up. You know, so you can just go mess with those, okay? But it's to study your notes. Study your notes. Make sure you understand.